Christoph, let's start off by talking about psychedelics and the psychedelic experience. I jump straight into it. Is there something useful to be learned from direct experience with psychedelics?
It depends what you're after. It may often not be so much enjoyable as it can be revelatory
Mm.
if you do it with the proper set and setting. First and foremost, I really have to emphasize that some of these substances, depending on what you're doing, are very powerful. And as with any other medical technology or with any other technology that manipulates your consciousness, with power comes also danger. And so, they can be dangerous. And I mean that in a serious way. People can get seriously messed up. And I've seen that. So that is just as a preamble. Uh, in my case, I had a few quite extraordinary experiences, including one near-death experience and one full-on mystical experience. So I would say certainly as a human, as a journal, as a person who's interested to understand the world, as a scientist, and also as someone who's sort of trained in physics and philosophy, they can be extremely revelatory.
When reading about your experience, I think listeners of this podcast will be familiar with Frank Jackson's thought experiment about Mary the color scientist, who spent her career studying neurophysiology of vision, but inside a black and white room and using only black and white instruments. And she
This is a thought experiment, just to emphasize.
Yes, a thought experiment. But in the thought experiment, she supposedly learns all there is about the perception of color without ever experiencing it, until one day stepping out into the light and experiencing it. And the question behind this thought experiment is, has Mary learned anything new? And it struck me reading your work is that there is a sense in which you've kind of gone through this journey because you spent many decades researching consciousness and the brain predominantly from the scientific perspective. And then only in more recent times have you, I could say, opened up the doors of perception, exploring consciousness more directly through psychedelics. And so my question to you then, has Mary learned anything new? Have you learned anything new from doing these, from experiencing these interesting states?
Well, first of all, so I just have to correct you. When you say experience consciousness directly, I am always experiencing consciousness. In fact,
Yes, of course.
this is the only way you and I experience the world, through
Mm.
our perceptions, our feelings, right? And scientists have always acknowledged this. If I'm a physicist, I look at an oscilloscope, I see, and I hear measurement. I hear the Geiger counter go off, right? So those are all conscious perception. So everyone who's awake and not unconscious, as in deep sleep or anesthesia or in a deep coma, experiences the world. It's just that what psychedelics can do, they can abruptly cause you to experience things that are quite different from everyday experience. Is it higher or not? That's sort of a separate question. But you can certainly experience, among others, you can experience things that are spaceless, where all of space has collapsed, that are timeless, where your perception of duration, we're always embedded in this flow of time, always from the past into the future. We'll always have a feeling of passage of time, but under certain psychedelic experiences that can cease to exist. So you become spaceless, timeless, and certainly you can become selfless, where you experience the world, what Buddhists call a non-dual experience, right? Where you experience something, but the you is not, is sort of, there isn't this distinction between object and subject, between knower and knowing, between apprehender and apprehended, right? That is gone. So you experience something, but there's no self, no ego, no memory, no body, but you can be highly conscious of ecstasy, or of terror, or of, the bright light at the end of the tunnel, or things like that. So they can certainly teach you about very different states of consciousness. And then, particularly during mystical experience or during religious conversion experiences, William James, the American father of American psychology, wrote this wonderful book in 1902, The Varieties of Religious Experiences. He talks that people bring back, he mentioned that people who have these transformative experiences, another way of calling them, they bring back something that he calls noetic quality. They bring back something from this experience that you don't have to accept as an external person. But I just know I have experienced something. I know what it was. For me, it's without a doubt. In fact, very often people say this is more real than sort of everyday experience. And he calls it this noetic quality. And to get back to Mary, if Mary takes this psychedelic and suddenly she sees color, she brings back something to people who are all raised in black and white, and they say, I don't get it. What are you talking about? This is all, it's just your brain on drugs, right? There aren't any things like color out there. Where are they? I can't see them. All I can see is wavelengths. But which is entirely true from a third person point of view. But of course, as a first person, she can have color experiences like you and I. So in that sense, yes, you can have these noetic experiences and bring back something that for you is more real than anything else in life.
What do you make of the argument that, this is just then a drug-induced hallucination and we shouldn't take it seriously? The noetic sense that someone gets that they've learned something is a feeling like any other. And many people would argue, okay, well, that feeling is a feeling, the feeling is real, but does it represent anything actually learned? What do you make of that sort of line of argumentation?
Matt, I'm willing, so I know a lot of very wealthy people here in the tech industry. I'm willing to arrange a swap where I give you $1 billion, but you will never have a single feeling again, ever. You'll be just a zombie for the rest of your life. No loving, no fearing, no dreading, no wanting, no desiring, no seeing, no hearing, no dreaming, nothing. How does that sound?
Oh, it's the same as death. It's the same as if you said you would give me $1 billion and I would die.
Yes. So that's my point. So you can say it's just a feeling. The only way we experience anything, this goes back to René Descartes, is through our feelings. So it's the most precious things we have. So I also work with clinicians to try to build this conscious meter, a device that tests for the presence of consciousness in patients that are so-called vegetative state, or now they're called behavioral unresponsive. And there, where push comes to shove, you realize that people, what is most important to them, first, are they alive? If you get that call, your loved one has been in a bad traffic accident. First thing you want to know, are they alive? Second one, you want to know, are they there? Because again, being there means, do they have some experience? Do they have awareness of their own body, of their environment? Do they know what day it is, etc.? So that's everything that finally matters to us, are these conscious experiences of the world at large, and in particular, possible these extraordinary experiences. My consciousness exists in some absolute sense. You see, this bottle here of water, okay? This only exists for others, for me, for you, for my dog, for all sorts of other conscious entity. But by itself, what there is in physics, there's just particles all around. There are particles here in the air, nitrogen, oxygen, some rare gases. There's some other crystals here that make up the glass, but there's just stuff, right? For me to see and to realize that this is a heavy bottle takes a conscious mind. So in that sense, this bottle only exists in a relative sense. It only exists for others. So this is the fundamental sort of gap that runs through the fundamental division between things that exist for themselves, conscious entity, whether that's a baby or dog or an adult human person like you and I, or everything else that only exists for others in a relative sense. So tonight you are going to go to bed and you will fall asleep. And in the first part of the night, you'll go into what's called deep sleep, right? Delta, which is characterized by these slowly crisscrossing waves that I can pick up in EEG. At that point, you will cease to exist for yourself. If I wake you up in that part of that phase and ask you, Matt, did anything go through your mind just now? Typically, you will say, no, nothing. I came from nowhere and suddenly I'm here. Later on, in particular in the early part of the morning, you are still asleep, but you wake up inside your body and you have these experiences. We call them dream. So then again, you exist for yourself. So consciousness is really, in some very real sense, is absolute existence. And physics by itself, physical objects just exist for others, not for me and not for you.
There's still the question of what these more exotic types of experiences can tell us about the nature of things, if anything. A quote that of yours that really struck me on your website is you refer to Aldous Huxley's Doors of Perception and his concept of mind at large. And in reference to that, you said that your second experience triggered a seismic shift in the ontological grounds I've lived for most of my life.
Yeah, so this is what I mean by revelatory. So some of these experiences can be quite harsh in a somatic sense in what you experience, but then you can, as part of this experience, you can then, I mean, it's difficult to put into words. It's what James says, it's ineffable. You experience something. I experienced something. This was at 2 a.m. in the morning on a beach in Brazil under this glorious southern sky, where I disappeared. So myself was gone. Christof was gone. His memory, his body was gone. And I sort of became one with the universe, and I experienced mind at large, what Huxley calls mind at large, which to me, so I always grew up. So I grew up in a devout Catholic family, where sort of the ontology is sort of dualism, right? Like Cartesian dualism, right? There is the body, the brain, and there is sort of what Descartes called cognitive stuff, right? There's physical stuff like this bottle in my body, my brain in your brain, and then there is cognitive stuff, and sort of under most interpretations of Catholicism that would also include the soul, right? But then, as a scientist, sort of, obviously, I don't believe in that in this conventional Catholic notion of a soul anymore, because how does the soul interact with the body? That's always the causal interaction problem, right? But I was always very clear, and way back when I started to work on this with Francis Crick, the discoverer of the double helical structure of DNA, he was very interested in consciousness. We got together and wrote, 20 papers or so on it, and I was always very sure that no matter what, there is something about consciousness that cannot be explained away. And you can't just tell me it doesn't exist. It's for me, it's, we talked about it. It's more real than anything else. But so you become comfortable, okay, somehow there's a physical stuff, and then the physical stuff somehow either emerges out of, maybe the conventional explanation is, okay, you got very complicated physical stuff like brains, like our brains that has on the order of 100 billion neurons. Each neuron is connected on the order of 50 to 100,000 other cells, vastly more complex than any computer, 5,000 different types of cells. And out of this complexity somehow emerges, quote, consciousness. But then it's unclear how this emergence ever takes place. No one has ever satisfactorily explained that. How can neurons, no matter how much stuff you pile onto more stuff and more stuff, well, how do feelings suddenly emerge? It's a complete, right? This is the explanatory gap. This is what David Chalmers, the Australian-American philosopher, calls the hard problem, right? You can't, there's this gap, this chasm, this explanatory canyon between, on the one hand, physics, and on the other hand, feelings. Why is if I'm in pain, for instance, all there is fundamentally are ions sloshing around in my brain. There's sodium and calcium and potassium ions that move in and out of nerve cells. That's ultimately what happened. Why should they give rise to this awful feeling of a toothache? And some other neurons, some other ions sloshing around somewhere else give me an orgasm. How is that supposed to happen, right? Okay, so this is the problems. And so then over the last 20 years of my life, I've shifted towards this theory of consciousness called the integrated information theory that posits sort of, that says consciousness comes first. Consciousness needs a substrate in order to express these various states of consciousness. But first and foremost, what exists is consciousness in this absolute sense. But then what this mystical experience left me, and why I said it sort of shook up and shifted sort of these tectonic plates in my understanding of the world, which at my age isn't all that common anymore, is that I said, gosh, these idealists, they've got it right. Ultimately, what there is mind, and everything ultimately is reducible to mind. So it's not, there's physical stuff and then there's mental stuff, which is sort of, either panpsychism or dualism. But no, ultimately, sort of what this experience seemed to have revealed is that ultimately there may only be mind, and all this physical stuff is ultimately a manifestation of the mental. So that's a very different view that has also an old pedigree, right? In at least in Western European cultures, it was popular in the 17th, 18th, early 19th century, particularly, of course, the philosopher Arthur Schopenhauer. And now some people are beginning to revive idealism for the 21st century.
It does open up a really curious line of questioning, though, when you think about some of the other work you've done on the neural correlates of consciousness, because if there is sort of only mind and mind is primary, it is also very strange then that very specific sort of brain states would conceivably correlate very well to particular states of mind or states of experience. And I mean, there is certainly this interaction between the physical stuff and what the experience is. In a way that feels very precise. And you mentioned David Chalmers. I think famously you lost 25 years standing bet with David on whether by this stage we would understand the neural correlates of consciousness. And I would actually also be interested to know why you took different sides of that bet, why your view is that we would have had it mapped by now, and and David's view is that we
Well, I
wouldn't.
mean, look, you're also an entrepreneur. You tell me you work in startups, right? No one ever starts a startup. I'm probably going to fail,
Yeah.
right?
Oh no, they
That's
do. They
not
do.
how
It's
you
just
get
that the
your first
upside.
funding.
It's just that the upside is big enough to make it worth the risk.
Well, look, of course, you're right. Probably, sort of, as a rational thinking that anytime you do a startup, you're probably going to fail. But certainly from a psychological point of view, you don't operate that, right? You operate with this charismatic. You're going to try to convince everyone that this is the best thing since the invention of sliced bread, and you want them to give money. And as a young professor, when you're just starting a lab, you have that same faith. Yes, of course, me and all my colleagues, together with all these powerful brain imaging techniques and microelectrodes and molecular biology and whatnot, brain-machine interfaces, of course we're going to solve the problem. Plus 25 years, when you're 30, you just got your faculty position, 25 years is, it's a lifetime away.
Yeah. Dude, what is your current position? Like, do you feel that there is something to be gained from, would we be able to map the neural correlates of consciousness and develop that mapping from brain states to at least a subset of possible conscious experiences?
Yes. Yeah, there's no question. So David, so this is not the hard problem, right? The bet that Dave Chalmers and I made wasn't the hard problem, but will there be generally agreed upon NCCs? In other words, will the community agree the neural correlates for seeing color is in this part of the brain and neurons, let's say, firing at a particular frequency or synchronized? Or, and hearing the voice of my daughter is in that part of the brain. That's a question that will have an answer. We haven't found it yet. Will we find it in 25 years? Maybe. The brain is by far the most complex system humanity's ever encountered. As a single organ, it's by vast the most complex piece of highly active matter in the known universe. So it might take us longer. But there's no question, and David and I agree on this. Ultimately, there will be answers, and this will be critical. For instance, to understand, consciousness in you and I. To understand when is the baby first conscious? Is it as a third term, in utero? Is a fetus already conscious, or does it first become conscious when it exits the birth canal and cries? Or what happens in late stage dementia? When does consciousness stop? I just mentioned early on, there are roughly 1 million patients worldwide that have so-called disorders of consciousness following a stroke, a cardiac arrest, a TBI, etc. Many of these patients, within 4 or 5 days, people will withdraw. The medical team, together with the clinical personnel, will decide to withdraw clinical support, i.e., to withdraw ventilator support. Although we know now in 20% of these patients have what's called covert conscious. In other words, they are conscious, but they're unable to signal that to an external observer at the bedside. So then there are other pathologies like schizophrenia, when people hear voices, right? All of this involves understanding the neural correlates, the molecular correlates of consciousness. So knowing this is incredibly valuable. But you can ask, okay, from a So from a scientific project, it's a very legitimate project. There will be an endpoint. There will be Nobel Prizes given out, lots of companies. It'll help lots of people in psychiatry and in neurology. Now, what about ontology? What about the classical mind-body problem? Will that sort of make the problem go away? So it's interesting. So as I said, I worked with Francis Crick, and we had many discussions, he and I, where he said, well, maybe it's going to be, maybe, he wasn't sure, it's going to be like in molecular biology, that once Jim Watson and I saw the double helix, the double helix, the pairing of the base pair, it became immediately clear how information is copied, right? You just have a copy and the complement, and then you rip them apart and the next. So that's how you can copy genetic information and pass it on. It immediately became clear, and historically, within a few years, that was accepted. It was never very controversial what they found, okay? And he said, maybe that's also true for consciousness. Maybe once we understand what are the exact mechanisms, the exact neural correlates of consciousness, people will say, oh yeah, of course, that's how it goes. Problem solved. Let's move on to the next big problem, origin of life or origin of the universe. But he also, and we did this together for 14 years till he died. Towards the later years when we did this, he was less and less convinced of that and thought, no, we somehow need some new tack on this. We need to look at it. Maybe we do need to look at it more from a theoretical perspective. We met several times with Giulio Cenoni, who's the father of this integrated information theory. Because it's not clear, even if you know exactly these neurons and, encoding these proteins in this part of the brain sort of fire or active every time you have a conscious experience, why that should be so? Why so? Why these neurons and not those neurons? Why this gene but not that gene, right? Why should any bit of matter feel like something? And so it's not clear whether solving or discovering the neuronal and molecular, and even if they're quantum mechanical correlates of consciousness, why they should feel like something. That is an open question.
I mean, there's almost a sense where, going back to the hard problem, where I feel if you look at any scientific endeavor, if you ask the question why for long enough, you eventually come to a point where it's either just purely mysterious or you kind of have to assume something. You have to assume something is fundamental. And you can come up with any example. Gravity, for example. Look at the history of our understanding of how gravity works. No doubt many centuries ago it was wrong, and but we've had several sort of landmark moments where our understanding has improved. Newton had his theory of gravity, which was also not complete, but it had a universal law of gravitation, and then Einstein had general relativity, and now there are speculations on quantum gravity and where does string theory get involved. But at the end of the day, at some point, something has to be assumed as fundamental. And I've always found it quite curious that in the case of consciousness, the hard problem has been put on a sort of like a categorically different footing from all of these other questions. Because again, if you ask why, I don't see how it can't at some point end with something that has to be fundamental and assumed.
Well, so I guess you could go back to Aristotle and ask, of the why, of the four causes, which one are you interested in, right? So science in general, as you point out implicitly, science is not very good at why question, right? The question of what, in biology, right? You can ask, why do we have two eyes? Some creatures have 8 eyes. Some creatures have compound eyes. Those sort of questions are very difficult. And you can always spin some sort of evolutionary story, but whether it's true or not, you never know. Why do we have electric charge? Well, it's not. You can go back to standard model, but why are there 15, I can't remember, or 17 different parameters in the standard model, right?
Yeah.
I agree, but at least in physics, let's say with gravity, right, where today's understanding as it relates to curvature in space-time, one has more of a sense of mechanisms. And here, the idea of mechanism is just a complete puzzle, how any mechanism, no matter how so construed, can give rise to, because it's just so radical different, right? On the one hand, you have quantity, like like mass and charge and spin and things like that. And on the other hand, you have feelings like pain and pleasure and seeing and hearing, and they just seem to be so. I mean, that's why René Descartes makes so much sense, right? Yeah, sure, there's physical stuff, and then there's mental stuff, and maybe this is just the way the universe is. It's just a brute fact that we have to accept. But yeah, and so that may be in the fullness of time, in 100,000 years, we might just be at that stage where we say, yep, all we know, this is the only universe. And then, of course, people will get the multiverses. Oh, there are going to be other multiverses where you have creatures like you and I, but they won't be conscious, right? And that's perfectly compatible with I mean, again, this was one of Chalmers' argument, right? You can perfectly well imagine a world identical to ours, where the same scientific laws of physics, chemistry, and biology hold it as in ours, but there's no consciousness. And right now, we know nothing that contradicts that.
Yeah. Oh, I have reservations about that particular conceivability argument, which we should get to. But maybe just on the practical question of developing a neurocorrelative consciousness, and maybe looping in the topic of psychedelics where we started with. In a previous conversation I had on this podcast with Thomas Metzinger, he asked me if I thought there was something to be learned from the psychedelic experience, and something that I answered to me was that what it does reveal, which is quite practical, is that it seems that the mapping between physical states of mind and the resultant conscious experience is very sensitive, because a very, very small chemical change in the brain leads to an utterly profound change in the conscious experience. And to me, this casts some doubt on the actual practical feasibility of finding robust mapping, because the input space to output space map is very, very sensitive. And that, to me, casts doubt on our ability to develop sort of an accurate neurocorrelative consciousness understanding, even in principle. What do you make of that line of thinking? Like, is that input space to output space so perhaps too sensitive that we will never actually be able to develop that mapping?
A priori, it is very sensitive. Look, all I need I can cut off your oxygen for 10 seconds, right? I don't, and you'll lose consciousness, right? Right? If someone chokes you within 10 seconds, typically you lose consciousness. Yeah. And 100 microgram of LSD can send you into, hell or heaven. All that means that the system is very sensitive. It's very complex. It has to be very complex because it gives rise to the amazing diversity of conscious experience, right? Think about all the concerts you've been, think of all the music, all the paintings you've seen, all the books you've read. All of that is a distinct conscious experience. Cause that with your bodily states, with, it's just mind-boggling. So I'm not surprised that the brain is so sensitive to all those things. If you take a simpler animal like a C. elegans, presumably it's far less. I don't know about LSD and C. elegans. The C. elegans is a tiny nematode, a tiny roundworm. That's one of the favorite objects people study because it only has 1,000 cells, of which 312 are nerve cells. It presumably has many fewer states and is somewhat more robust. So I don't see, yes, it's going to be very complex. I grant you that, Matt, but I don't buy into this defeatist argument that we might not understand it in practice in great detail. We might need, things like LLMs, detailed computer simulation to actually predict what, if I look at your brain, what you will actually experience, or that might be forever beyond our ken based on not knowing all the initial conditions, et cetera, et cetera. But that doesn't mean, at least in principle, we shouldn't be able to understand why in what part of the brain you will have what type of conscious experience.
Okay, well, let's maybe touch on some of the topics then from your most recent book, which is called "Then I Am Myself the World." In the book, you put forward. There we go. For those watching, it is on the screen right now, and I'll link it to the show notes as well. In the book, you put forward a case for, as you've just mentioned, integrated information theory as a theory for how consciousness sort of arises. And then on this basis, you make several very significant and some practical claims as well, which I would like to get to. And for listeners who want to get details of integrated information theory should read your book. But for purposes of this conversation, could you please give me just a brief overview of the core claims of integrated information theory and how it works?
Okay, so the integrated information theory, or in short IIT, is sort of an unusual theory because it starts off with some very explicit definition of what it means to exist, which is extremely uncommon in science. And it starts out with 5 axioms of consciousness. So it starts with consciousness. But the theory is a work of Giulio Tononi, who's an Italian-American psychiatrist and neuroscientist here in Madison, in the Midwest. So it starts off by saying it's really a consciousness-first theory. It says what exists in an absolute sense is consciousness, and every conscious experience, including every near-death experience, any psychedelic experience, whatever experience you can conceive of, will have 5 properties. It exists for itself, not for others. It is highly differentiated. It is the way it is. When you experience LSD, well, then you have a particular very unique experience where there's no more self, and you might see colors and weird stuff happening, but it is what it is, different from trillion of other experiences. It is one. It's integrated. It's holistic. Right now, I don't have 3 separate experiences. I have one experience which integrates maybe sounds. I can maybe, if I shift my attention, I can feel the pressure of the seat on my behind. I can see you, but it's all one integrated experience. It's definite. It has some content, right? Right now, my experience is very particular, right? It's seeing you on the Zoom screen. It excludes a vast universe of other things, and it's structured. Every experience has something like parts in it. It has, in this case, it has left, right, up, down, distance, spatial overlap, etc. But even when I'm dreaming, or even in my near-death experience, it had no space, no time, no self, but it had an incredible bright light. It had terror and it had ecstasy. So every conscious experience is like that. Okay, so those are the 5 axioms you start off with. And then you say, okay, let's look at existence. Because you want to take those axioms and say, okay, in order for something to exist, it has to have causal power. And you take those. So this goes back to a discussion in Plato, where Socrates meets a stranger from Elat, which is historically supposed to be where Parmenides started from. And the stranger, the philosopher Parmenides, sort of says, well, what exists is what causes. Only what causes can be said to properly exist. So IIT generalizes that and says for something to exist, it has to make a difference and take a difference. In other words, it has to be an agent of change, or someone else has to be able to affect it. This is a widely used principle, although rarely acknowledged as such. In physics, for instance, right? The electric charge, can cause things to move closer or farther away. Same thing with gravitational, right? Curvature in space-time can make things fall, for instance, or accelerate. And the theory says consciousness is identical to causal power of a system upon itself. So you take a system like a brain, and you put it in a particular state, like right now, these neurons are firing and those neurons are not firing. And in this state, it has some ability to determine its next state, right? Because otherwise, obviously my brain has that, and your brain also, because what I say makes sense. So in other words, my brain has sort of some way it can articulate to cause me to say things in a regular way that makes sense to you. Right? So it has some causal power, and that's ultimately what consciousness is. It's causal power it's the ability of a system in a current state to affect its future and to be affected by its past. This is something very practical, so you can download Python code if you go to the website integratedinformationtheory.org. And for any system, whether it's neurons or transistors, as long as you have what people call a transition probability matrix, which essentially says, have these 20 transistors or these 100 neurons, and if they're in this state, with 90% probability they'll go to that state, and with 5% probability to that, and with 5 into that. And you do that exhaustively for the entire system. So as long as you have a complete description of a system like that, you can compute how much causal power it has upon itself. And you can do two things. The quantity of consciousness is this number called phi. It's integrated information. It's a pure number between 0, when the system, strictly speaking, doesn't exist as a whole, but it can be reduced to some of its parts, or a number that when phi is bigger than 0. That's really the way to think about it. That's the quantity of consciousness. It's also how irreducible the system is. The larger the integrated information of this particular system right now in this state, the more it is a whole, the more it is irreducible. So that's the quantity of consciousness. The quality of consciousness, how does any experience feel? Why is pain painful? And why is space extended? And why does time flow, etc.? So the theory says and shows it in a qualitative, in a mathematical formal way, that the actual causal power of a system that a system has, when you analyze all of its subcomponents, those 3 neurons and those 4 and those 5 neurons on these, if you unfold all of this intrinsic causal power, that essentially is identical to the way any conscious experience feels. So it's quite radical because it says it's identical. It maps 1 to 1. So you take the intrinsic causal power of a system, you unfold it in this mathematical way. That is identical to the conscious experience of this particular mechanism in this particular state.
Yeah, about, I think it was around a year ago now, a large number of neuroscientists signed, there was sort of like a paper went out and many signed, kind of against integrated information theory. And the central sort of underlying claim they were making was that integrated information theory is a form of panpsychism and is not even in principle testable. And for this reason, shouldn't be considered real science. They considered it sort of a pseudoscience. What do you make of this sort of general line of thinking that integrated information theory isn't sort of testable in practice in a standard scientific way?
Okay, so first, this is highly ironic because the only conscious meter that right now is around that consciousness detector. So there is this very promising development over the last 20 years that was initiated by Giulio Tononi and then by one of his postdocs, who's an MD, PhD, Marcello Massimini, to test for the presence of consciousness in people. Now, this is where the rubber hits the road, okay? As I said, let's say you get a call, your loved one just had a bad car accident, goes to the ICU, is put on a ventilator, so this person is clearly alive, but doesn't respond. You ask him or her, can you hear me? Can you move your eyes? Can you move your feet? Can you wiggle? Whatever. They don't respond, okay? And then, as I mentioned before, if this lasts more than 3 or 4 or 5 days, the doctors will typically initiate a discussion with the family. Well, is this what they would have wanted? And in 80%, 4 out of 5 patients, they decide to discontinue life support, okay? Now, we know that 20% of these people are actually conscious. So the device that has a high sensitivity right now seems to be a device that comes out of IIT. So what you do, you put in a device called transcranial magnetic stimulator, TMS, that essentially sends a magnetic pulse. You can put it outside. It's a big figure. So it's a coil, with many loops of wires. You put it here and you send a brief current into it, and it generates, using Maxwell's laws, it generates sort of neural activity in the cortex underneath it. So it's essentially like, you hit your brain, but, magnetically speaking. And then you're looking at the reverberation of that using EEG. So you have a 64-channel EEG, and you're looking how the brain responds to this knock. So think of a bell. You hit a bell with a hammer, and you're listening to the echoes. And essentially, based on the theory, the 2 axioms of every conscious experience has to be highly integrated and highly differentiated. It essentially approximates this in a very crude way. It's a very crude approximation by measuring sort of essentially the Lempel-Ziff complexity of the resulting EEG response. And it turns out there's a threshold, 0.31, if you are in this normalized way of doing things. If your threshold is below that 0.31, then either your volunteer was deeply asleep, or you're a volunteer who's been anesthetized, surgical level anesthesia, and is therefore unconscious. Or you're in a state where, without any doubt, you're in a deep coma where people believe with 100%, or I mean, as close as it gets in medicine, that you're not conscious. If the complexity is above that number, you're either a volunteer who's awake, like you and I, or you're a normal, typical, healthy person who's in a REM sleep, where you dream, or you're neurotypical when you are under ketamine dissociation, where you're dissociated from the environment, but you're clearly conscious. Right. So you can use this device as a practical way, and people are testing it now. There's a clinical trial being run here at MGH, at Harvard, and in Madison to try to test this, to see how you can integrate this into the clinical workflow. So I find it highly ironic, this claim that IIT is in principle testable, because it doesn't, this is not, the mind-body problem can sound very often very abstract, airy-fairy. This decision that that people have to make is one of the most grimmest and toughest decisions. Is this person conscious or not? Because if they're not conscious, very often, it's you pull the plug on them. Okay, so then people say, well, but that's just a crude approximation. Okay, so so maybe the theory had this intuition and the intuition was right, but you can't in practice compute it. But so if you go back to 17th and 18th, 19th century physics, the development, following Newton, when you look at Lagrange and Hamilton and other people, most of those quantities, like the Lagrangian of a cloud of gas, in practice couldn't be computed because you have 10 to the 23 particles, right? And so, but people didn't despair. They developed, things like various approximations, like universal gas law, right? Where you say, well, under a certain condition, you got an ideal gas, you get PV equals nRT, right? So just because something is difficult to, and there's no question, the scaling, because you have to look at within IIT to look at all the causal power, you have to look at all possible subsets interacting with all possible other subsets, that scales as 2 to the 2 to the n. So even with 10 neurons, you get 2 to the 2 to the 10, that's 2 to the 1,000, that's bigger than, that's a larger number than all the atoms in the known universe. So right now it does scale pretty badly, but that's not a principal objection. So we will have to do, just like we did in physics, we'll have to develop, and people are trying to do that, various approximation, symmetry consideration, or other things to allow us to reduce, looking at the causal power of a human brain with 100 billion neurons to something that we can actually compute. So I don't find that a principal objection. And then the claim that it's panpsychist. Whoa! Horror upon horror. I mean, that's ridiculous. We cannot judge a theory on whether we like the outcomes of it or not. If the theory tests and the test turned out to be valid, well, then we have to look at its implication. And if it says many more things have some conscious experiences than our culture, particularly Western culture, that's sort of based on, human universalism or triumphalism, that we are really the only conscious creature, well, maybe we have to reject that. But why does that make it anti-science?
Yeah, but it does bring up such an interesting question of why there is such a division then, because, I mean, we've said several different things. We've talked about the hard problem and the fact that there is this sort of strange categorical difference that we have when thinking about the hard problem versus some other questions in science, when at the end of the day, something has to be assumed. And we've talked about the fact that the only thing that we can know for certain exists is consciousness, because we're all experiencing it, and everything else comes through the sort of filter of experiencing through consciousness. And so, I mean, all of our science, anything else we believe, it has to come to us through a conscious experience. Perception comes first. And all of these things, and yet there is quite a, I would say, amount of controversy, or quite a divide in how people think about this this question among...
But that's exactly what I would expect. If you see a once dominant paradigm, you can think of this, are we living through a Kuhnian, Thomas Kuhn, the American historian of science, philosopher of science, are we living through Kuhnian paradigm shift? And then, of course, the old paradigm, sort of materialism, aka that morphed from materialism into physicalism, right? That everything can be fully reducible to essentially to physics, right? to mechanisms, nothing else exists. This was really what Dennett's project, right? Dennett's project was really physicalism and only trust third-person measurements, right? Don't trust, because in the final analysis, so Dennett was a very smart guy. I really liked him. I had many debates with him. But he sort of, in the final analysis, he said, your conscious experience aren't really what you think they are. They're just behavioral dispositions. That's all there is, behavioral dispositions. Right? You have a very complex thing, and when you say you are in pain, what you really mean, you're going to rub your jaw, you're going to avoid eating on that mouse, you're going to moan, but fundamentally there isn't the badness of pain, the qualia humbug, he said in a famous interview with the New York Times. Okay, so he and people of his ilk, they've tried for more than 100 years to try to cancel consciousness, right? To gaslighting us into believing, well, you don't have pain, you don't have pleasures, none of that really exists. You're just terrible confused about it. But then, of course, if you accuse them of that, they say, oh, no, that's not how I mean. Well, how else do you mean it, for heaven's sake? You're telling me it's illusionism, right? That's what they call it, illusionism, right? So it's all a big illusion. But if this is an illusion, how do I know that anything exists, right? By what measure does anything exist? Because it's the only illusion I know of for certain. So I think physicalism so far has... So there are three reasons why I think you can think about other ontologies. Physicalism has so far failed to offer a remotely satisfactory explanation for conscious experiences. It doesn't mean maybe it can in the future, possibly, but it hasn't so far. B, if you talk to, and I know you've spoken to people, you've interviewed, I saw on your website with Tim Maudlin or other people who deal with the philosophy of physics right now, in particular after the Nobel Prize for Bell's inequality and these entangled pair of electrons. Well, if you look at the fundamental level, what physical is, what material is, we have no idea. Right? You take two particles, you entangle them, you put them on opposite side of the universe. And as soon as I measure, they're indeterminate, right? So unless something interacts with them, I don't know, are they like this or are they like this? And then as soon as I measure this thing, even though this one may be half a universe away, it immediately determines that, well, the other one has to be like that. Well, that's not my grandfather's definition of reality, okay? And so we don't know, we don't know how to explain consciousness. At the rock bottom, we don't know what physical is. And now many physicists themselves think maybe we need to incorporate consciousness at the very root, at the rock bottom of reality. Maybe they're inexorably linked. That's true. And then you can have these personal experiences, you bring back this noetic quality. So the first two we can talk about at length because we can talk about and do potential experiment. The third one, this noetic quality, of course, has this quality that only the experiencer brings back from this experience. Well, I said, look, I know. I don't have to convince anyone else. No one else has to believe me, but I know ultimately there's mind at large. So then the challenge is for a thinking person like you or I, okay, is there a way that we can reconcile all of that, right? Because at the end of the day, I'm still a thinking person and a scientist, and I'm trying to explain my own experiences using the framework of science, enlarge maybe a suitable revised sense of science, including an ontology, what truly exists.
Yeah, I mean, there's a lot in there. One thing that stands out is, I think most people, and I would include scientists in this, do have a pretty deeply held intuition that if a system is functionally appears conscious, I would say, if functionally, let's say you could replicate as much as possible of what a human being does, it is very, very hard to not see it as conscious and not to think about it as conscious. But what's interesting...
You mean like LLMs?
Like an LLM. And it's very interesting in your book, you actually kind of use the sort of foundational theory of consciousness to make some pretty interesting claims about the possibility of consciousness emerging in these systems or being present in these systems that divorces the actual existence of a conscious experience from the sort of specific functions that those systems might be performing, in a sense that you could have two different systems doing the same thing, one of them with experience and one of them without, which strikes me as very counterintuitive, and I assume for a lot of people they would think the same. So maybe let's get to that topic. The prospect of engineering conscious systems is one that's talked about a lot these days, and in particular, as you said, LLMs. Many people worry about consciousness even accidentally emerging within sufficiently complex LLMs. And the theory you put down makes some predictions and some claims about the possibility of this. Can you tell me about those predictions and whether you think it's worth worrying about consciousness emerging in an LLM?
No. I mean, yes, I can tell you about them, but no, it's not worth worrying about them. So as many people, including Nick Bostrom in the opening page of his very good book, Superintelligence, point out, we need to worry about the long-term future or the medium-term future of humanity. There is an existential risk there, but it has nothing to do with consciousness or sentience. That's just a different word, or awareness or subjectivity. Those are all just different words, meaning effectively the same. Even if a AI, as I believe, doesn't feel like anything, it could be a threat, right? Because if all it wants to do is, maximize whatever the ROI is, right? Whether that's killing enemy soldiers or maximizing return on money and investment, it does what it does. That's just inherent in its design, whether or not it feels anything. So I don't think consciousness is anything particular. In fact, you can make the opposite argument. You can make the argument that once you have consciousness, including the possibility of empathy, that makes a big difference, because so particularly here where I live, we're very much concerned about the fate of orcas, these beautiful killer whales. Here in this particular subspecies, there are only 72 orcas left. We have empathy with them, right? We want to save them from going extinct, because we can sort of feel to a certain extent with them. So I would say, if at all, consciousness might actually help us. Why do I think LLMs cannot be conscious, or their computers carrying out LLMs? So, according to integrated information theory, it's not a functionalist computational account of consciousness. So let me back up. Most models of consciousness today are so-called come out of this movement called functionalism, part of physicalism, that ultimately anything to explain something, I just have to explain its function. And once I've explained its function, that's all there is to explain. Then I've explained everything worthwhile explaining. So in particular, there's this thing known as computational functionalism, or by the American philosopher Putnam, or Turing machine functionalism. It's really the same, that consciousness has one or more functions, like to speak or to plan, or what to be, to respond in a particular way to certain things. And once I have explained that function of those functions, then that's it. Problem solved, okay? IIT is very different. So IIT says, among others, it's very easy to show that you can take two boxes. They're wired inside. One, let's say, has a neural network that's just feed forward, or one stage goes to the next, goes to the next, goes to the next. Or I have a second box that's much more complex, has all sorts of feedback connections, okay? They have the same input, do the same output. And I can show that under certain conditions, they're identical. The same inputs will lead to the same output. So IIT says the one that has a feed forward has zero integrated information, is not a single entity, because it's essentially a series of smaller entities. It doesn't exist at the level of entire box. Its integrated information is zero. It doesn't feel like anything. Yet the other one, if it has lots of feedback loop, can be an integrated whole, can feel like something. So the theory says there cannot be a Turing test for consciousness. You have to look under the hood. You actually have to look at the mechanism that gives rise to this processing, okay? It's nothing to do with the input-output. Unlike intelligence, where, of course, we know we have things like the Turing test, right? And so by this, even if you could replicate something like a human speaking perfectly, well, okay, you have to admit it's an intelligent thing. It can learn from, it's like a vampire. It sucked up, 100 million human human books and other human texts, and it can regurgitate that in a very intelligent way, but that's nothing to do with consciousness. And then furthermore, that's coming out now in a more satisfactory sense, you can actually show very specifically using the calculus of IIT. So on the assumption that IIT is a correct theory of consciousness, you can actually show I can have two networks. One, let's say it's a simple physical network, a bunch of circuits that have some cause-effect power that are conscious. And then I can map this onto a finite state automata that can simulate identical the state of this physical system that I want to simulate. So again, input, output, it's exactly the same. And you can expand this system to be a generalized Turing machine. You can show that even though they have the same functional input, output, this one can feel like something, while the simulacra doesn't feel like anything, or feels only like a tiny itsy bits. It doesn't feel, because again, of the structure, particularly the big differences between our brains, because the theory doesn't say there's something magical about brains, right? It's not that we have something that no other physical system. It has to do with the causal power, ultimately with the connectivity. So if you go inside a brain, a cortex, a human cortex, you have one neuron that gets input from 50 to 100,000 other neurons and projects to 50, 100,000 other neurons, input, output. They have massive overlap. That's radical different from a transistor in a CPU, where typically you have 3 or 4 I used to build them, where you have 3 or 4 wires that go into the channel or that go into the gate of another transistor. You have very low connectivity in the CPU or the ALU of a computer. And so the integrated information of the digital phenomenon machine as they're currently construed is tiny, and you can show you can get a dissociation. You can program different things on this phenomenon machine. In each case, it's only tiny bits. Its causal power is tiny, and it doesn't matter whether you watch a movie or whether it's a simulation of the human brain. It's a little bit, the metaphor or the analogy I use is, if you write down the 10-dimensional equations of general relativity, right, and solve them for the mass at the center of our galaxy, right, Sagittarius A star, you can turn on the computer simulation and you simulate the central mass. It weighs 3 million solar masses, and you realize it's a black hole. It's so powerful, it bends space-time around it, nothing can escape. But you don't have to be afraid that you're going to be sucked into the computer simulation. And people say, well, of course not. It's a simulation. Well, this is also true for the LLM. Of course not. It's a simulation. It doesn't have the causal power of the human brain, and you need to build the causal power of the human brain in order to get human-level consciousness. So it may be possible that if you use what's called a neuromorphic computer, where you have one transistor talking to 100,000 transistors, let's say simultaneously, not with a clock, digitally, that might be highly conscious, or maybe a computer, a quantum computer, because if you get very high degrees of entanglement, that's effective, like a very high connectivity. And so it may also be possible that quantum computers may one day become as conscious as we are. But right now, the digital computers that we have in the cloud that run GPT-4, and even that will run GPT 5.0 whenever it comes out, will not feel like, they'll feel as much as my vacuum cleaner or my garbage disposal unit. And so, although I admit, they're very powerful.
Yeah, they're
intelligent, but they're not conscious.
They've certainly convinced, I think, an increasingly sizable number of people that they might be. So just to make sure I fully understand it, there are certain types of information processing that integrated information theory would say is conscious. There is another class that has zero integrated information, but that achieves the same input-output results that is not conscious. And
yes,
those two things are true. Does that at all? Doesn't that make it a little bit? Does it feel weird then that humans, biological beings, mammals, say, would be conscious? In the sense that both of those, we've said that both of those types of computation are complete. Any processing can be done in those two sort of buckets. any computation could be done.
Yeah,
Is that correct
but you would
understanding?
never get. But for instance, linear feed-forward systems or von Neumann systems are in terms of what you mentioned, sensitivity to initial conditions, it's extremely unlikely. So if you play evolutionary games, so I used to do this when I was at Caltech, we did this, we coded up a simple genome that would give rise to a brain, that would brain in a little automata and send them through a maze, and then we would select the top 10% performers. We'd perturb their genome somewhat randomly. They would give rise to new neural networks that we could put into automata that we could send through the maze, and we do this for 100,000 generations. And that at some point, of course, you're going to get machines that perform, or these automata that perform quite well and rapidly run through a maze, right? Because you evolved them, you simulated evolution. You'll never get anything remotely close to what you get in electronics, because you get these random connections every which way. It's a random search in extremely high dimensional spaces, right, of connectivity. And you can show, and there has been a few papers of that tends to maximize it. That tends to maximize causal power. And so in the extreme case, you would never get a feed-forward network. It's simply not generic. It's simply not and generic. And any tiny perturbation in the genome would add a connection from here to here and from there to there, and a back connection and a sideward connection. So it wouldn't be generic. So that's why it's relatively easy to explain why, in terms of evolutionary within IIT, you would get systems that are highly complex, that give rise to high degrees of consciousness.
Does this theory have sort of like ethical implications for how computation is done and how machines are built? Because it almost puts guardrails around what can be the architecture of systems such that they won't be conscious, or won't be conscious in particular ways, hopefully in the future. Did you feel like that is a legitimate line of inquiry?
I mean, Thomas Metzinger has thought about that, mentioning him. Because it's right now, I mean, we're riding still the tail wave of Moore's law and the von Neumann architecture, right? 80 years old, and it's still very, very powerful, and there's really no true alternative right now. And so under those conditions, von Neumann machine, because of these bottlenecks, I think consciousness, sentience simply isn't in the cards. As long as we have those machines, I think there's no need to worry about it. Once you get to quantum computers, yes, then it's different. So some people are trying now to apply the IIT calculus to quantum systems. What is more worrisome, though, is something you pointed out, which is as a sociological observation. It is true that more and more people believe these machines will be conscious, or maybe are already conscious, and will behave to the extent that these machines integrate into our lives and are truly integrated in our lives and are everywhere. People will, of course, because we have this attribution, right? We attribute agencies to our cars, to our pets, to all sorts of things here. So, of course, we will attribute agency to them, whether that's good or maybe whether that further dehumanizes what is unique about the organic. And I think the latter. So I think it's a dangerous development that we're now undergoing, which is very difficult to stop, to reverse.
Yeah, I certainly worry about that one as well. And I think, I mean, not to get too deeply into an ethical rabbit hole here, but already today there are beings that we're pretty convinced that everyone would think are conscious, and we don't treat them very well. And and I think having
exactly to your point.
Yeah.
To your point, yes. So yes.
Yeah, exactly. Well, let's talk about the measuring consciousness. So we briefly touched earlier on the you mentioned it was almost an irony that IIT was criticized, even though it is somewhat the basis of the actual only device we really have that in a real practical medical setting can measure levels of consciousness. And I know this is an area that you've been involved in through some time, and you even have you're working on a company that works on such a device. Tell me about this. Tell me about this prospect of measuring consciousness?
Well, okay, so it's not really. So in my earlier, when I first wrote about it 10 years ago, when it came on the horizon, I talked about measuring. It's really, we're much more cautious now. It's detecting. There's really, because this measure is so crude, it's not a real measure of phi, integrated information. It's a very crude approximation. Given the fact that I'm looking from the outside, I have to perturb this brain with its 100 billion neurons. Even if I just focus on cortex, it's 16 billion neurons. Right now, there's no way, we don't have access to those neurons, right, particularly from the outside. And we need some readout that we can actually get done today in the clinic and not waiting for some, science fiction technology in 100 years from now. So in that sense, we talk about a detector. It can, with pretty high sensitivity, remarkable high sensitivity, detect whether this person right now, as we do the test, whether they're experiencing something. Which is in general is good news, because if you know the patient is covertly conscious, the chances of recovery just statistically seem are roughly 2 to 3 times better than if the patient is not conscious. Just in terms of longer term functional recovery, because that's typically the third question that people ask. First, are they alive? B, second, are they there? Third, when will they recover?
Is there any prospect of understanding the nature of that experience? So again, you can imagine, let's say, a patient with locked-in syndrome. Are they locked in a state that's neutral, in a state of bliss, in a state of suffering? Because of course, the ethical implications of understanding that would be enormous for determining what to do in terms of medical
So
treatment for that person.
paradoxical, Matt, for the locked-in state, actually, it's relatively easy to evaluate if you put EEG, because the EEG looks normal. So in a locked-in state, so that's what happened when you have a stroke in the pons. Typically, you're unable to move, except maybe you can move your neck a little bit, and you can typically move your eyes down, vertical, up and down, and you can blink. And there's a very famous book written by such a patient called The Diving Bell and the Butterfly, the French editor of Elle, who had a stroke, came to, woke up inside his body, but was, for the rest of his life, was confined to this extreme form of solitary confinement. And he dictated an entire book. And we know from survey of such patients that in general, unless they suffer from chronic pain, they want to live. And they can, once they normalize, for you and I, it's utterly unimaginable. This is a thing called the paradox of disability, where healthy people like you and I, particularly if you're very active and do trail running and climbing, you cannot imagine living even in a wheelchair, let alone, locked-in syndrome, where you say, I don't want to live like that. Please pull the plug. But most people, once they get into this state, or many people at least, can adapt to these terrible circumstances, unless they have chronic pain. That's a separate discussion. But when they don't, they adapt, and then they, as long as they can communicate, they clearly tell you they prefer this state over not being. Okay, and locked-in REM, so it's not that difficult to detect. You put an EEG on them, they will have relatively normal waking and sleeping. And as I said, some of them, they can communicate. So it's more these cases when you have this. Terry Schreiber was a very famous one. So you have a person that had a heart, cardiac arrest. She's like this for 3, 4, 5, 6, 7 days. Sometimes she might do this, but you don't know, is it just a reflex? Just some uncoordinated movement. Some have spasms, like this. Some of them will recover. Typically, they have no memories of this. So it's not clear, even those that are covertly conscious, to what extent that consciousness translates into memory. We know, this is, of course, what happens early on in our life when little babies, are clearly conscious, or little children, but typically they don't have any reliable autobiographical memory before the age of 2.5 to 3, before they start to speak, right? So something similar seems to happen in these patients. I've never read a report of what it feels like to be in this state of a patient. It may happen, but it's certainly not. I haven't come upon such a autobiography.
Well, what is your vision for how this technology might develop over the next, let's say, 2-3 decades, and maybe not even just not a prediction, but what would you want to happen? Like if you could have the ideal world, the correct level of investigation, investment, people focused on this, what would it look like? What would be built over the
Every
next?
ICU, every emergency room, everywhere should have one of these devices. It should just be like, any other device, because so many, I mean, as I said, roughly the million of these disorders of consciousness patients worldwide, most are acute, which means they resolve within 3, 4, 5, 6 days. Either they die naturally, or they recover some functionality. Today with fantastic medicine, some people can almost go back to totally normal, or people discontinue life support. But there's a small set of patients that can stay, like Terry Shivo is a good example. She lived almost 14 years. So with proper nursing care, some of these patients can live, many, many years. Although most of them, as I said, roughly 80% are probably unconscious. There's a big paper coming out next week in New England Journal of Medicine that does a multi-center survey of these. And I think they claim up to 35% of these patients may in fact be conscious. So I think that's an impetus to further develop these technologies and have something like this in every, that if you're you come into unconscious, routinely they would apply this test to see, are you really unconscious, or are you just unable to signal or unable to hear? Or, so for instance, you may have heard there's one test for consciousness that people developed 15 years ago, where you put one of these patients inside a scanner and you ask them, can you imagine walking through your house? Or can you imagine playing soccer? And then, in this case, this young woman who crossed the street and was hit by 2 cars simultaneously, massive brain traumatic injury, Glasgow coma scale, like 3 or 4, so no behavior. How do you measure? Because how do you measure behavior right now? How do you measure consciousness right now? By behavior. You ask people, move your eyes, or move your finger, or say something. When they can't, you're assumed unconscious. This lady, she could willfully modulate her brain activity. But that takes effort. It takes, in fact, even healthy people like you and I, if I put you in a magnet, I make you go through the same task, only in 80% of the time does my detector actually respond. Because for many minutes you have to focus, just think, don't get distracted, just focus on, imaginary walking through your house, or just focus on playing tennis, imaginary playing tennis. And so some people may simply not have the cognitive capability. The advantage of this test, this NOC test, is that it doesn't depend on active cooperation of the patient. The patient doesn't have to do anything, because you're directly probing the integrity of the cortical thalamic system, which most people believe is a substrate for consciousness.
Are these devices used in practice currently in actual hospitals anywhere?
Yeah, so right now they're being tested in a variety of places, in Liège, but it's still very experimental, in Milan, in Italy, and then, as I said, at MGH and in Madison and at UCLA. So at a few places, like any medical technique, you have to show, well, okay, this is fine in theory. It's a research prototype, but now let's put it into the clinic. How easy is it? How much training does it take? How big is it? How long does it take to apply? Right? If it takes 6 hours to apply, it may not be feasible, particularly in the chaos of an emergency room or an ICU. So, and then of course it has to be approved by the FDA, etc. So it'll take some time for this technology to sort of diffuse into the clinical, to be accepted and diffuse into the clinical medical community. But I think it will happen, and it must happen, because there are just far too many people that die although they're conscious.
Problem I'm intimately familiar with getting new technologies into the healthcare space.
Yes.
Christof, maybe I'm conscious our time is coming short. Maybe loop it back to the first topic we started with. We've talked now about patients who we're detecting whether or not they're conscious, and this dictates treatment pathways and even whether we decide to continue or to end life support. And that question of what happens at the end, when the lights go out and losing consciousness, it's one of the biggest questions that there is and something people think about. And often the psychedelic experience or other forms of sort of introspective or exotic experiences, it changes how people think about death and their relationship to the question of their own mortality. And I would love to ask you, through your experiences, maybe through psychedelics, but more generally, how has your thinking about mortality and your own mortality and the own sort of end of your consciousness, how has that progressed and evolved?
Well, two things have happened. One, I had this near-death experience in the first week of the pandemic, and I discovered a few weeks after that experience, I never had this brooding that I had slowly developed. As you get older, it's natural. You lie in bed, you brood about what does it mean forever, to be dead forever, right? And, it's not just a long time, it's not just a very long time, but it's, and then it's sort of, I at least got this existential vertigo. It's like, when you climb, it's like you look down into an abyss that has absolutely no bottom. And it's very uncomfortable feeling, of course. And it's sort of, you just ruminate. It's useless. It doesn't do anything, right? After my near-death experience, for reasons I don't fully understand, and this is not uncommon, it's a characteristics of many near-death experiences, I totally lost that. I haven't had that brooding not once in the last 4 years. So that's just a positive psychological gift that I've received. Furthermore, if you're some sort of idealist or even a dualist, of course, this always raises the question, well, so can the mental coexist without the physical? So IIT, to be very clear, says no, right? Within IIT, once there's no more, or once the physical substrate comes apart, in death, you're not an integrated system anymore. Now, a minute or 2 or 5 or 10 minutes later, the neurons fall apart and start firing incoherently or stop firing altogether. Then that's it. Consciousness is gone, and it doesn't go into any hyperspace. It's simply gone. So you, with your memory, etc., you're gone. Now, if you're an idealist like Schopenhauer was, of course, there's this other possibility. So the way I think about idealism, particularly sort of the way that Bernardo Kastrup, the living computer scientist and philosopher, who sort of has revived Arthur Schopenhauer, and he calls it analytical idealism, that ultimately what exists is this vast thing, this cosmic consciousness. And we, for a brief time, 100 years, 80 years, whatever, we are just like eddies. Think about a river, and there are these eddies, these little currents, right? And they have their own identity for minutes or hours or days, right? And sometimes they can merge with each other, but ultimately they will dissipate, right? These structures will have their identity, but ultimately they'll dissipate and they'll go back into this underlying river or ocean. And so that's one way to think about it. So what that means, you will die again. You, the Matt, in your predilection and your likes and dislikes and your autobiographical memory and all of that will be gone. Right? So there's no paradise here in any conventional Christian sense, but you will go back to the state you were in before you were born, into this universal consciousness. And so that's a very different way to think about that ultimate transition. We will see,
we will see.
It's a question that one day we will all, every one of us, will all undergo this final transition, and then we'll see what state we end up with.
Yeah, well, definitely. If it's first for me, I'll let you know, and please do let me know.
Yeah, that's the challenge. Communicating from there.
Exactly.
Yes.
Christof, it's been such a pleasure. Let's bring it to a close with a question I like to ask all of my guests. They're all very well read. They're very well written as well, and they've been influenced by many people, and I know you have as well. A question I would love to ask you is, which book or books have most influenced you in your intellectual journey?
Schrödinger, What is Life, probably, Erwin Schrödinger. Schopenhauer, I read as a very young, as a teenager. The Doors of Perception, I read that a long time ago. These are some of the books that, and then one book of Einstein about Relativity Explained, that he wrote himself, sort of a popular book. These are some of the books that I really liked as growing up.
I would guess that What is Life would have been an influence of Francis Crick as well. I'm not sure, but I would guess.
Yes.
Yeah.
Very explicitly, he told me many times about because what Erwin Schrödinger wrote about the possibility of a code, right? This was first really very clearly expressed by Schrödinger, that there's this code. And if we can just learn that code, then we would understand what makes life. And then, of course, they discovered the physical substrate, the molecule, and then Francis participated into the genetic code, right? The triplicate code with the nucleotide and all of that, the N codons, right? So they did decisively solved that problem.
Yeah, I've actually forgotten the exact timelines here, but did they overlap? Did they ever meet?
Did they meet? I don't recall him ever telling. Oh yeah. I mean, because there was 1953. What is Life was published during the war in 1942 or 1943 when he was in exile in Ireland, but he was still alive till into the early 1970s. So I assume they must have met, but I don't recall him mentioning that right now. But that's a limit. It's a good question. I don't know.
Well, Christof, as we bring it to a wrap, I'm sure people would have gleaned a lot from this conversation, and many would like to follow up. Where would you like to send them? Where can people find more of your stuff?
The easiest probably christofkoch.com, just like my first name and my last name.com. In my last book, I try to be, it's a popular book, Then I Myself, the World, which is it's named after a mystical experience, in this case in Tristan und Isolde.
Oh, maybe let's close with a little bit of explanation of that title.
Well, it comes from Selbst dann bin ich die Welt, which is the second act of Tristan and Isolde, Richard Wagner, where they merge. So you have these two lovers, sort of illegally, in some sense, and they want to overcome their separation from each other, and they think, Tristan, thinks he wants to become Isolde, and Isolde becomes Tristan, and then they have this, what can only be described as a mystical experience, which you can also think it happened 3 times in a row. So it's like, having 3 orgasms on stage, where they become one with the world itself. And this, of course, was written by Richard Wagner when he was under the influence of Schopenhauer, The World and Representation. So it's definitely, suffuses, entire opera is suffused with Schopenhauer's idea of idealism and going beyond the unreal physical representation to encounter the absolute.
Fantastic.
Well, and it's also one of the most rapturous music written in the standard Western canon.
Maybe I'll see if I can find one that I can exit this podcast interview with.
There should be many. I mean, the best one is Jerusalem. If you Google Jerusalem, Tristan and Isolde, very powerful. That's a lovely idea. I like that a lot. Let's do that.
Very good. Well, Christof, it's been an absolute pleasure. Thank you so much for making the time. It's been a pleasure having you on.
This was enjoyable. All right.